Now, what about the concept of limiting reagent or limiting reactant? So here is a balanced chemical equation, and if I were to ask you, what is the limiting reagent in this problem? Typically, what that is asking is, you take your two amounts, so maybe silver nitrate started out as a solid prior to being dissolved in solution, and so you had copper that you have a certain amount of grams of, and you have silver nitrate that you have a number of grams of. And if those two react, how much product is created? And so maybe your product that you're concerned about is silver. You want to create pure silver. And so how much pure silver are you going to create? That's a limiting reagent problem. If you only have one product and you only have one reactant and excess amount of the other reagent, then it's not a limiting reagent problem. Limiting reagent problems are where you have two amounts or three or four. You have a whole bunch of things that are being added together, and you're trying to figure out how much a product is actually created or theoretically created. Better way of saying that. Okay. So how do we do this? How do we determine what is the limiting reagent in a problem? These are some steps here that are kind of the quick and easy way to say what's the limiting reagent. They're not always the way I do it, and I'll tell you about that in a second. But this way is you take your number of grams of copper and you take your number of grams of silver nitrate, and you convert both of those into the number of moles using the molecular weights that are appropriate to the compound or atom. Then you divide by the coefficient. So you take the number of moles of copper and you divide by 1, take the number of moles of silver nitrate and you divide by 2. And then whichever of those two values is the smallest number, that's your limiting reagent. What that means is you now can use those number of moles, not the part divided by the coefficient, and you can translate it all the way over to get it to product. So say I have 5 moles of silver nitrate. That's equal to 5 moles of silver because they are 1-to-1 to each other. Okay, and then you then take number of moles of silver and convert that into grams of silver product, and that's your yield. So get used to these words: theoretical, experimental, your yield. All of these things are related to the idea and the concept behind limiting reagent. So oftentimes that's what I would do, is I would, instead of just doing this and then coming up with this number here, this ratio, that's a ratio. I instead like to just simply take my grams of copper, work the stoichiometric amounts to get me to product. And then I might do the same thing here with the silver nitrate, figure out how much silver could be created based on the amount of silver nitrate I started with. And then once I have those two numbers, the amount of silver created from copper and the amount of silver created from silver nitrate, now I can ask myself which number is the smallest. And whichever one created the smallest product, that was my limiting reagent in the problem. And so really, these types of math is just simply ways of saying, hey, in the real world, we go into lab and we have finite amount because we're trying not to waste stuff. But in a worksheet, we might just say excess, because either the reagent's cheap and we don't care, or it was a way of simplifying the problem so you can focus on the chemistry happening. And so the idea of limiting reagent is just very important in chemistry because we don't always have the world where we have plenty of excess of whatever other reagent we have. Sometimes you have very similar amounts and you have to calculate from both of them how much product is being created, and that's your theoretical yield. And so review these ideas, calculate limiting reagent however you best want to, but to be able to answer the question of which one's the limiting reagent is an important concept that I find is very valid in analytical chemistry.